However, risk officers and science leads resisted, citing anomalous preliminary data, the possibility of misinterpretation, and the requirement for interagency review, language typically reserved for planetary defense events. The phrase media-driven speculation outweighing public trust appeared in more than one internal memo. Every mention of unusual chemistry or unexplained optical effects was replaced by bland assurances of ongoing analysis in the days that followed. Draft statements were edited and re-edited. The silence wasn't just about what was shown, it was about what was withheld. Under standard 6-month restrictions, the European Space Agency withheld raw KSSIS data, but even summary statistics on polarization and spectroscopy were reduced to the bare essentials. All inquiries were redirected to headquarters by NASA's Mars Reconnaissance Orbiter and Perseverance teams, who only released the annotated Skycam frame. Both the Hope probe in the United Arab Emirates and the Tianwen-1 in China, which are both equipped to collect unique radar and spectral data, did not post any updates or even confirmed any attempts to observe. The usual rhythm of science, raw files, quick looks, engineering logs stopped cold. Space policy experts are aware of the pattern. Competitive agencies rarely coordinate their silence, especially when a high-profile discovery is at stake. The last time anything like this happened was during asteroid flybys with planetary defense implications, when early data could trigger panic or confusion. But this was a comet, not a threat. So what kind of anomaly could force 4 agencies with different priorities and rivalries to hold back everything, except the most secure preview? Some cited the possibility of misinterpreting subtle signals, or stoking wild speculation regarding artificial origins. Others speculated that deeper disagreements existed regarding how to verify and evaluate the initial indications of unusual polarization or out-of-the-ordinary chemistry. The coordinated quiet left the scientific community in limbo. There were questions that outreach teams were unable to answer. The rumors that the real story was hidden in embargoed files were fueled by amateur astronomers who attempted to match the Skycam detection, but were unsuccessful. The only thing that could be said for the time being was that the world's top space agencies had decided to wait because of something in the preliminary data, whether it was a calibration error, a physical anomaly, or just the fear of a media firestorm. The expectation of open science had collided with a wall of caution, and behind it the data waited for a verdict. 3 Atlas was never supported by probability. The object's path, just 5 degrees off the ecliptic, threading between Mars in October and Jupiter's orbit in March, defied the odds. ESA's Space Situational Awareness Office ran the numbers. The chance of a random interstellar object following this geometry is less than 1 in 10,000. The trajectory alone raised eyebrows, especially with the flyby sky patch brushing so close to the coordinates of the 1977 WOW signal. Official memos dismissed the overlap as coincidence, but the statistical unlikelihood fueled debate among mission scientists. Spectroscopists found themselves staring at an even stranger puzzle. Strong atomic nickel lines Ni were observed in the early cross-cheese spectra from JWST and VLT without any trace of iron. In comets, nickel and iron usually traveled together, liberated from grains by heat or ultraviolet light. Even though nickel production rates increased with each approach to the Sun, iron was absent from this location. On August 21st, the VLT logged a nickel production rate near 10 to the power of 22.7 atoms HS with a scaling law so steep, falling off with heliocentric distance to the ETH power that it outpaced any known cometry behavior. Nickel carbonyl, a volatile compound that forms in carbon monoxide-rich environments and breaks down in mild heat or sunlight, releasing pure nickel atoms, is one pathway that laboratory analogs point to. It is an industrial process on Earth. It's almost unheard of in space. The chemistry team at DLR and INAF looked for natural explanations that fit the numbers because there were no iron carbonyl signatures or FEI emissions. The coma itself, sampled by JWST in the near-infrared, told a second story. Carbon dioxide made up 95% of the detected gases, an extreme, almost unheard-of ratio. Water, the staple of most comets, was barely present. Some theorized that long interstellar exposure could drive off water ice, leaving heavier volatiles behind. Others wondered if the ratio hinted at something more deliberate, artificial outging or propellant use, though no direct evidence supported that leap. The CO2-rich coma served as a chemical fingerprint for the time being, which is uncommon in nature but not impossible. Optical measurements added a final twist. KESIS and VLTS-FS2 both recorded